So welcome to everybody who is just joining us. So we're going to begin our live training session. I'm Matt Shell, aka Matt Mirafish on Twitter. And today's live session is called Intro to Shooter Mechanics. So what we're going to be looking at is two different methods for shooting in games. The first being a raycast or hit scan technique where we're casting an invisible line into the scene and then getting information about the object that we're hitting with that line and using that to either apply damage or display particles or sort of a variety of things that we can look at, and we can look at some of the alternatives. And the other technique that we're going to look at is launching a projectile into the scene. So in this case, it's going to be an object that's going to be driven by physics. And for our example, we're going to do a gun for the raycast and then a grenade for the projectile-based shooting. Now, one of the things I really want to emphasize to you guys at the top here is that we're going to show these techniques with the context of a first-person perspective and a shooting game, but these are really versatile techniques that you can use for much more than shooting, especially the raycasting technique. And I'll talk about that as we continue. But so first of all, let me just show you. We have here, let me open my demo scene. And I'll show you guys what we've got and what we're going to learn. So you should now be seeing the Unity editor. I'm going to play my scene. And so when I click on I have a reticule, right? I'm using the default first-person character controller, and I've attached this arm and this red dot reticule, and then we have this man who's our target here, and when I click on him, it instantiates these particles, and then if I click on him 3 times, he will disappear. And so I'll just reset the scene. That is our raycast-based shooting technique, and then we also have this we also have this technique where we can launch a projectile into the scene, which is going to spawn a particle system and also apply some physics forces. You can see the guy, I'll show you again, you can see the guy goes flying up into the air. So you can see he kind of gets bounced around there. And so those are the two techniques that we're going to look at. I'll show you a kind of beginner, easy way to do it, and then we'll also show a slightly more intermediate technique where we're applying the damage using what's called an interface in terms of the scripts, which I think will be interesting for those of you who are already familiar with the basics. All right, so as far as the chat, I believe that none of my colleagues are with me tonight, so I am going to pause as I get through the topics and check out the chat and talk with you guys. Since it's just me, please try to keep the chat focused on the material at hand and questions related to the material. I'll stick around a little bit after the session in about an hour and can answer more general questions about things besides the material. But for now, please keep the chat on topic and I'll check in with you guys when I get a second to take a break. So what I'm going to do is I'm going to open up, I have a scene that is my scene where things are not set up. And so here we have the first person character, and I've added these little debris here, these cubes that we can bounce around with our grenades. And what I've done is I've taken, this is from the VR samples, this disembodied arm here. This is from the shooter example in that project, and the man is also from that project, as is this this maze mesh here. I've just pulled those right in. You really don't need this artwork to do this project. It's really not specific to that, so I'm not going to recommend that you download it or follow along. I would just say, watch the session, focus on the concepts, and of course, I'll make the scripts available with the archive. All right. So what we're going to do is we're going to start with our shooter weapon by adding a new C# script. So I'm going to choose add component, and I'm going to type in the name raycast shoot. So I actually already have my demo script, raycast shoot. So I'm going to call this one raycast shoot script, just to make it different so we don't have a conflict. Since it's not existing in the project, I'm going to hit new script, and then I'm going to hit create and add. I like to use this approach because it will both create the script and add it to the game object that I have selected, so that I don't forget to drag and drop it on. Let's double click it to open it in MonoDevelop. So now we have a new empty script. And so we're going to start by declaring some variables. The first variable that we're going to declare is going to be a public float called fire rate, and we're going to initialize that to 0.25. So this is going to mean that every quarter of a second, every 250 milliseconds, is going to be as often as the player can fire. And so next, we're going to set a public float called weapon range, which is going to be equal to 50. So the range is going to be the distance that the raycast goes into the scene. From the, in this case, from the camera away from the camera into the scene. And this will be 50 unity units, which is equivalent to 50 meters. Then we're going to have a public particle system called shoot particles. This is a particle system that will be played when we fire our weapon. And this is actually, we can see it, it's attached to the gun end. This was actually part of the shooter gun artwork. It's a child of the gun end, and it's here. And if we can, it's a little hard to see, but it's just a little sort of, couple little dots there, a little sort of smoke-ish particle system. So we're going to play that when we fire. And then we're also going to have a public game object called hit particles. Hit particles are what we're going to instantiate at the spot that we hit. So if you remember when I was shooting the target, the enemy, we saw those yellow sparks appearing. And those are going to be a prefab, which I've already created, called hit particles. And we're going to spawn those at the point where we shot our target. Next, we're going to have a public integer called damage, and we're going to initialize that to 1. So this is going to be how much damage is going to be applied to the enemy each time we shoot them. Next, we're going to have some private variables. I'm going to have a private camera called cam. Let's call it my cam, actually, because the autocomplete will get annoying if I have cam in there. And then what we will also have is a private wait for seconds called shot length, and we're going to initialize this to a new wait for seconds with a length of 0.07 of a second. So 7 milliseconds? No, 70 milliseconds. Very short. We'll talk more about why we're declaring a wait for seconds here when we get to use it. But basically, this is something that we're doing, which is going to make our scripts a little bit more efficient. And then we're going to declare a private audio source called source and a private float called next fire. The audio source is what's going to play our shooting sound effect, and next fire is going to keep track of whether enough time has elapsed for us to fire our weapon again. Now, I'm going to change my start function to an awake function, and I'm going to get references to my components. So the first thing that I'm going to do is get a reference to my audio source. So I'm going to say source equals get component audio source. So this is going to get a reference to the audio source that's attached to the same object that this script is attached to. So in this case, we have an audio source here, and I've actually got the shooter weapon sound effect, which is that pew pew sound that you heard before, this guy. Pew. So I've already set that up in advance, but basically it's just an audio source with that in it. We're going to get a component reference to it in Awake so that we can play it when it's time to fire our weapon. Then I'm going to get a reference to my camera. Now, the camera is not actually attached to, the camera is a component that's not attached to this game object. So I'm going to use getComponentInParent. GetComponentInParent allows us to search upwards up the parent-child hierarchy and look for the component that we're trying to get. So we're on this shooter weapon game object, which is a child of the first-person character object here, which does have the camera attached. So we're going to start searching up. The first one we find will be this camera, and we'll store a reference to that in MyCam. Okay, so, I see Duck has joined us. Thanks for joining us, Duck. Good to see you. Duck's a member of the documentation team at Unity, doing heroic work over there. And so what we're going to do then in Update, so Update is run every frame, and we are going to use this to check if the player has pressed the button and if they has pressed our fire button, which in this case we're going to map to left click. And then if they have, we're going to cast our ray into the scene and see what we've hit, and then do some stuff with components attached to the object that we hit. So the first thing that we're going to declare is a raycast hit called hit. Now, raycast hit is a data structure that contains a bunch of additional information about the object that we hit. Now, normally when we do a raycast returns a Boolean which just says true if we hit something, anything, or false if we didn't hit anything within our, in this case, our 50 units range, right? With a raycast hit, we can get a lot of additional information, like the collider attached to the object that we hit, the surface normal, the rigid body, a whole bunch of different information we can store in that raycast hit and then do additional things with the object that we hit. So that's actually an important part of this. So the next thing that we're going to do is we're going to declare a vector3 called ray origin. So this is going to be the point at which our raycast, our invisible line that we're firing into the scene, is going to originate. And so we're going to be doing it from the camera. And so we're going to say ray origin equals mycam dot viewport to world point. Now, we're going to feed, I'll explain what that is. Let me just finish the line. So we're going to pass in a new vector3 and give it the values 0.5f, 0.5f, and 0. So what this is doing is if we look at our game view, the game view is a two-dimensional view, right? A two-dimensional representation of a three-dimensional environment, right? What we can do using viewport to world point is to take a point on this two-dimensional plane, which is the near clip plane of the camera, which we can see if we go into the scene view. We can, might be a little bit hard to see, but basically you see that box there? So this is actually our viewport. And so we can get a point on that plane and translate that to 3D world space. So we're translating from the 2D coordinate system of screen space to the 3D coordinate system of world space. And so 0.5 along the X and 0.5 along the Y gets us right to the middle of the screen where I've already set up this red dot. Optionally, the third argument is a Z-axis dimension in Unity units. I've set it at 0, so this is going to be 0 at the position of the camera. So basically, this is just giving us an origin point at the center of the camera's view. But translated into 3D world space. The next thing that we're going to do is we're going to check if input dot get button down fire 1. So we're going to see, has the player clicked the left mouse button, and if, so I'm using that double ampersand to say and next fire time.time is greater than next fire. So has enough time elapsed since we last fired for us to be allowed to fire again. And if not, it's just going to ignore that the button was clicked and wait until the time has elapsed and the player will push the button again. So the first thing that we'll do is we'll say, okay, if that's true, then next fire is going to be equal to time.time plus fire rate. So fire rate was our float variable that we declared here to be 250 milliseconds. And so we're saying each time the weapon successfully fires, we're going to add 250 milliseconds to time.time. Time.time is the time elapsed since we started running our application. And so we're going to see, has enough time elapsed for us to fire again in our if statement? And if so, we're going to set the new time that we're allowed to fire again by adding fire rate to time.time. This is a pretty common way of gating any time-based input. Once we've done that, we're going to cast our ray. So we're going to say if physics.raycast, and then we're going to pass in our parameters. So the origin is going to be our vector3 ray origin. That's where we're going to start from. The direction that we're going to cast the ray in is going to be our camera, mycam.transform.forward. So forward relative to our camera. And the fact that it's relative to the camera is important, right? Because the camera is going to be turning and looking in different directions. So we always want to be forward relative to the camera. Okay. Then we are going to pass in the third parameter, which is we're going to use the out keyword and pass it the raycast hit called hit that we declared. Now what this does is it allows us to effectively return additional information from the function. So the function by default returns a Boolean saying true or false if we hit something, but now we can also get this additional information about what we hit. So the point where the hit occurred, the game object, whether there was a rigid body or a collider, and so on. So we are going to, and then we are going to, the final argument that we're going to pass is the weapon range, right? The distance that we want to cast over. Now, if we hit something, right, because remember that physics.raycast returns a Boolean, our if statement now is going to evaluate to true. We're going to do the following inside the if statement. We're going to say enemy health damage script. So we're going to declare a new variable of the type enemy health called damage script. And we're going to set that to equal hit.collider.getComponent enemy health. Now, I'm going to actually show you later on when we get to the grenade portion of things another way to do this using an interface, but right now I'm going to show you the sort of simplest, most direct way, which just assumes everything that we want to shoot and damage has a script called enemy health. And then a little later on, I'll show you an approach that's a little bit more flexible. Excuse me. So now we're going to check if damage script does not equal null. So we want to find out, was there a damage script? Was there a enemy health component attached to the thing we shot? If there was, then we are going to instantiate our hit particles at hit.point. So we're using the raycast hit has a variable called point, which is a vector3 position in our world where the raycast hit whatever it hit, right? So we're going to use that hit.point and say, okay, at the point where you hit, let's create some particles to show that point was hit. And we're going to say hit particles, hit.point, and then I'm going to pass in quaternion.identity, so there's going to be no rotation, but if you wanted to, let's say, have an object rotated in the same direction as the gun, you could pass in transform.rotation as well. The particles are sort of spherical, so it doesn't particularly matter, but that's up to you. You can modify that if it makes more sense. And then we're going to call damage_script.damage. So our damage script has a public function called damage. I'll show you in a moment. And then we're going to pass in our damage variable, our integer damage, which currently equals 1. We're going to pass that in as a parameter when we call this damage function. So let's save that. There is another piece that we're going to add to this where we play the sound and show some effects, but the core interaction here should now be working. So let's jump back over well, let's test first, and then I'll show you the damage script. So now we'll wait for it to compile, play, and now let's see. No, it's not working. Oh, of course, I didn't assign the particles. So let's drag in our flare particles for the shoot particles, and then we have a prefab here called hit particles. We'll drag that into the hit particles field. And let's test. 1, 2, 3. So we can see that it's working, right? It's playing our particles, it's applying the damage. And so let's take a quick look at the enemy health script. Very simple script. Basically, we just have a public integer called starting health, which is equal to 3, a private integer called current health, and then in start, we set current health to equal starting health, so our current health is equal to 3. Then, when we call the damage function, we tell it how much damage do we want it to inflict, and then we're going to say current health minus equals damage, so we're going to subtract damage from the current health total, and then we're going to check if current health is less than or equal to 0, we're going to call the defeated function, which in this case just sets calls GameObject.setActiveFalse and deactivates the object and makes it disappear, right? But you could put in, you could play a sound effect or play an animation of the enemy dying or all kinds of things in here. This is not the main focus, so I'm just keeping it simple. But the key really idea here, and this is true for shooting or for many other mechanics, is we're casting array into the scene. We're using getComponent on the collider that we hit, and then we're calling a function from that script, right? Above all, this is the concept that I want you to draw from this, that we can use raycasts to reach out into our scene, get a reference to a script or get information about an object, and then do further things with it via script. That's kind of and that could be used, let's say, in a block placing game, right? You could cast a ray in and say, I want to place a block at this location, or you could, use it to spray paint the walls, or use a Star Trek tricorder to scan an enemy and find out what its weakness is, or anything that you can think of, right? That involves casting a ray into the scene and then doing some interaction with it. So we're showing shooting because shooting is a popular mode of interaction in video games, but I want you guys to think about also that this is, fundamentally just a way to cast a ray into the scene and interact with something. So I'm going to pause. We will finish this script in a moment. I'm going to pause just to take a look at the chat and make sure everything is going okay and take some questions, and then we'll continue. Let's see how we're doing. I'm going to scroll back a little bit. I see Duck has been talking with you guys, which is terrific. Thank you, Duck. All right. I see some people asking some off-topic questions. I'm not going to answer those. If you want those answered, just save them until the end. Okay, Jorche or Horche asks, is there a way to debug that raycast? Yes, there is. There is actually a function in the Unity API that Benno754 mentions called debug.drawRay, and that will allow you to visualize, not actually in your game, but in the editor, where that ray is going. I am not shouting asks, why instantiate hit particles as a game object instead of using the particle system? To be totally honest with you, I had a issue which is maybe a bug, where I originally wanted to just move the particles and then play the particle system again. But what was happening was that I would play the particle system once and then I would move it, call particle system.play and particle system.stop, and it just wouldn't play again. So I filed a bug report. I think it's fixed in 5.4, but in this version it wasn't working, so I just went with instantiate. But of course, instantiate might be useful for other applications as well. But yeah, I think that was actually a bug with the particle system. But under normal circumstances, yes, just moving the particle system and playing or emitting some particles should be fine and would totally work. Paradox Forge is asking, how much more efficient is this compared to the physics engine? This is using the physics engine. So maybe you could rephrase your question. GM Liquid Media asks, can a ray can in the shape of a cone where the far end of the ray is wide? What I would probably do with that would just be maybe 3 separate ray casts that are angled away from each other to make like a 3-sided cone or sort of pyramid. If you wanted a circle, you would probably have to do it a little differently. Yeah, we'll talk about sphere cast a little later with the grenade, which would be a sphere. Not quite what you're... All right. Okay, so Paradox Forge says, compared to rigid bodies and colliders, I think that this method is faster because we're using a rigid body and collider. We're either going to, in this example, we're going to instantiate. You might also need to do it with an object pool, but basically managing the projectiles in the physics system is going to be less efficient than just doing a raycast for one frame. Yeah, and as Solican says, if we were raycasting repeatedly an update, it might get expensive, but in this case, we're making sure it only fires once and then it can't fire again for 250 milliseconds, so it's pretty cheap. Yeah, if you were doing a shotgun blast, I would probably do a sphere cast. All right, so let's continue. So the next thing that we're going to do is, just to finish up the script, is just to add the effects that are going to kind of juice this up a little. So what we're going to do is we're going to, outside of update, we're going to declare a private enumerator shot effect. So we're going to use a coroutine. And the reason we're using a coroutine is because we have on our gun, we have this mesh which displays this kind of muzzle flash, this pink muzzle flash. And we are going to just turn that on and off quickly to do our muzzle flash effect. And you could add a light or some more animation or whatever you wanted. I'm just keeping it simple here. But so we're going to use the coroutine to turn it on, wait, in this case, for 0.07 seconds, and then turn it back off. And this is where that wait for seconds is going to come in handy as well. So the first thing that we're going to do is source.play, which is going to play our audio source, our sound effect, right? We're going to play our shoot sound. We're going to call shootparticles.play, shoot flare. Oh, I think I forgot to, forgot to declare. We need a public game object called shoot flare, which is going to hold a reference to this flare muzzle flash mesh. Forgot to put that in there. We're going to say shoot flare dot set active true. And then we're going to yield return shot length. Now, a lot of the time when you see people working with coroutines where they want to delay something, you'll see them do this: yield return new, wait for seconds 1, right? Or whatever. Now, this is going to create a new wait for seconds object every time we do this, and because this is going to be our shooting behavior, it's going to happen pretty often, so it's going to allocate a little bit of memory. So what we can do instead is just have a single shot length object that we store in this, or a single wait for seconds object that we store in the variable shot length, and then just return that instead. So just a little bit more efficient. And then we're going to call, after we've waited for our 0.07 seconds, we're going to say shoot flare dot set active false, right? So we're just really exactly the same as when I was just clicking to turn the object on and off to enable and disable it in the editor. We're going to be doing the same thing via script here. So let's save, jump back to Unity. We're going to drag references to those objects. All right, and so we are going to drag in our shoot flare and give it a test. Yep. What happened there? Did I not play my sound? Oh, there. Yes, I forgot to call my coroutine. In update, we want to call start coroutine shot effect. So that code is obviously not going to be executed if we never call it. So it's probably a good idea to call it there. So we're going to start our shot effect coroutine when we fire the weapon. Doesn't matter if we hit anything or not. We're still going to play the sound and the flash and stuff. Pew, pew, pew. There we go. All right. So now, you can see we have our sound effect that plays. We have our little flash. And all is well with the world. So that is a basic version of raycast-based shooting. I'll take a short little moment to answer any last questions about that before we move to the next topic, which is going to be projectile-based shooting. Let me just see how we're doing on time. Okay, 30 minutes. Yeah, I am not going to get into a full explanation of coroutines, but the utility of it here is that it allows us to delay the execution of this code, and it's running in its own time separate from update. Update continues to loop, and the coroutine can yield and wait before it needs to do its next thing while update is going. Yeah, there. Duck has just linked a tutorial about coroutines in the chat there. They're pretty useful. You can use them to run loops in or to delay pieces of code, or you can have them wait for another function to finish executing, for example. They're pretty handy when you need to do sort of time-based things in a script. Yeah. Okay, let me just have another sip of water and then we'll continue. All right. So that is one way to shoot, right? This is using a raycast. People also refer to it as hit scan. And we're going to look now at a second way to shoot, which is going to be actually launching an object into a scene. In modern shooting games, this would probably be a grenade, a missile, an arrow. Anytime you see something go flying into the scene and then it hits something, it's going to be a physics-based projectile, as opposed to, let's say in a shooting game like Counter-Strike, when you fire your submachine gun, you don't actually see bullets go flying through the air. You just see bullet holes appear and different things, which is achieved using a raycast or a hit scan approach. So what we're going to do is we are going to create a new script called projectile shoot script. Hit new script, hit create and add, and I'm adding this to the same shooter weapon game object. Double click to open it. Let me pull up my notes. Okay, so there's actually going to be two scripts to get this working. One is going to be this projectile launching script, which is going to be pretty simple. And then the other is going to be a projectile exploding and doing damage, which is actually going to be attached to the projectile. And we'll look at that as well. So first of all, we're going to have a public game object projectile. That's going to be our bullet or grenade prefab. Then we're going to have a public transform called bullet spawn. This is going to be the position in the scene where the bullet is going to be spawned from. Then we're going to have a public float called projectile force. We're going to set that to equal 250. And so that is, actually, let's set that to equal 550. I think that 250 was too low originally. And that is going to be a one-time push of force that is going to launch the projectile into the scene. And then we are going to, again, we're going to have a public float called fire rate and set that to equal 0.25, which we're going to use in exactly the same way that we did in our raycast shooting, just to gate the fire rate and make it so the player can't fire repeatedly. Then in update, we're going to do very similar. We're going to say if input.get button down fire 2, in this case, right click, and time.time is greater than next fire, we're going to, oh, I forgot to declare next fire. We're going to have a private float next fire. Whoops. Okay. And then we're going to declare a variable of the type GameObject, which we'll call cloned projectile. And we're going to set it to equal instantiate. So the object that we're going to instantiate is projectile. And so instantiate means make a copy of this prefab in the scene. So the prefab that we're going to make a copy of is going to be the projectile. The position we're going to make it at is going to be at bullet spawn dot position. And I'll show you where bullet spawn will be. We're going to use that gun end GameObject as a marker. And then we'll use transform.rotation. Now, my grenade is a sphere, so the rotation doesn't really matter. But if you want to launch like an arrow or a missile or something where the rotation matters, you should probably have it be rotated in the same rotation as the gun that's firing it. And we're going to cast it to a GameObject. So we're going to say as GameObject. Now, once we've instantiated that, we're going to get a reference to the rigid body component attached. So a rigid body is something that allows an object to be moved by the physics system and be affected by gravity and forces and so on. So I've attached a rigid body to our projectile. I'll show you the projectile in a moment. But what we're going to do is we're going to get a reference to that, and we're going to set it to equal clone projectile dot get component rigid body. So again, like we were doing with our raycast, we're going to instantiate an object in this clone projectile variable and then use that variable so that we can get a reference to the newly instantiated object's rigid body component. And then we're going to say, now we're going to use that rigid body component. We're going to say clone RB dot add force bullet spawn dot transform dot forward. So in the forward direction of the spawn point times projectile force. It doesn't want to autocomplete, but it's definitely there. Okay. So we're going to add force away from the spawn point forward and multiply that by projectile force. So we're going to push it away from the spawn point, and then we're just going to say next fire equals time.time plus fire rate. Okay, save. And that's actually all we need for that script. It's super simple, but should work. So now we'll just wait for it to compile. I'll show you so here's the gun end, right? I put a little red icon on it here. Can make it turquoise. That's the gun end, right? It's an empty GameObject that's holding the mesh, the flare meshes and the particles, and it's also marking the point where our bullets are going to emerge from. And so we're just going to drag a reference to that to bullet spawn, right? So we're going to use that transforms position. And then we have a prefab that I created called projectile. I'll just drop it in the scene so we can see it. It's just a sphere. And it has a rigid body component attached. It has a collider, which you'll get with the sphere. And it has a script called explode, which I'll walk you through in a moment. It also has a deactivated, let's make this invisible for a second. It has a deactivated particle system. Just looks like this. It's a little sort of not very attractive explosion particle system, which defaults to deactivated, and then will just get activated when the projectile hits something. So we can delete this and drag a reference from our project view to the projectile slot here. So that is the object that we're going to instantiate a copy of when we right click. Let's play our scene. Boom. And you can see, boom, it is landing in the scene, displaying the particles, and also adding some physics forces to the things that we hit, along with some damage. So let's take a look Or let me take a pause for a second, just if anybody has any questions about what we've done just now, and then I'll walk you through the explosion script. Yeah, so Gaius asks, shouldn't all physics stuff be done in fixed update? Basically, any physics stuff which is going to be done for more than one frame should. In this case, as Duck points out, we're checking for the button press, which is only going to be true for the frame when the button is pressed. And again, we've got that gating on it, right? So we just want to add that force for one frame. So there's not going to be a lot of variation. What we're trying to avoid is having the physics behave differently when the game is running at different frame rates. But if it only happens for one frame, it's safe to put like things like a single push like that in update. Yeah, as Duck explains, the down variants of the input function are only true for the frame that they're pressed, and fixed update does not necessarily, fixed update might not happen during the frame when you pressed it, so you would get glitchy input, which would be unpleasant. I am not chatting points out that I have both the scripts active. Yeah, I do. I want them both active because one is left click and the other is right click. Dude C 2004 asks, is there a way to add sound to the script like an explosion? Of course. We'll look at the explode script. I didn't actually put an explosion in there, but you totally could. Gideon 303 asks, how would you deal with multiple projectiles, e.g. player could choose to fire a grenade or a missile? There are a lot of different ways that you could do that, but probably just like in many games, you would have a button that would allow you to switch guns. And then you could, for example, deactivate the grenade shooting script and activate the missile shooting script when you pressed, let's say, the number keys on the keyboard. Would be one way to do it. I was talking about this recently with a coworker, and I think that probably it would make sense to have, right now I have one weapon called Shooter FPS weapon, but it might make sense to have like all the different weapons as child objects of the player and just turn them off and on so that you could have like the mesh, you know, the different gun artwork along with the different sound and the different scripts. That's probably how I would do it. Yeah, if you didn't care about all that stuff, you could just say, if you push 2, now we're launching missiles instead, and you could just instantiate a different prefab. That would also work. Okay, now we're talking about time travel. I cannot answer questions about time travel, so I'm going to keep going. All right, so the other script that we have is an explode script, which is attached to our projectile. And this is also a fairly simple script. I'm not going to type this one. I'll just walk you through it. So we have a public game object, explosion particles. That's that yellow particle system that will play. Now, it's worth noting, because this is a prefab, I put the particles as a child of the projectiles, and so that when they land, it just turns them on at the right location. So we don't need to instantiate those. We are instantiating the grenade, but not the particles as well. So just a little more efficient there. We have a public float called blast radius, and this is set to 1. This corresponds to 1 meter in the game world, which is a little small, but I just have a small level, so, you know, keeping it simple. But basically, this is going to be the distance from the point where the projectile hit that we're going to apply that explosive physics force around it and deal damage. So then we have a public integer called damage, which is set to equal 1. You might want to make it higher, but I'm just doing 1 in this case so the stuff doesn't get immediately destroyed and we can see it bouncing around. And then we have a private Boolean called explode. Now, here's an example of doing the physics code in fixed update because we might conceivably want to be applying forces over more than one frame. I am actually using fixed update here. So in this case, we're checking on, we have a function called onCollisionEnter, and this will be called here. We have a function called onCollisionEnter, and this will be called when the object that this script is attached to collides with another object. And so what we're going to do is we're going to turn on our explosion particles. We're going to call explosion particles.setActiveTrue, just turn on the game object, and that particle system has its play on awake parameter turned on, so it'll just play the particles as soon as the game object gets activated. And then we have explosion particles.transform.setParent null. So what this means is in the prefab, the particles are a child of the projectile, but now we don't want the particles to be destroyed immediately when we get rid of the projectile, so we're going to unparent them from the projectile. And I have another little tiny script that turns them off when they're done. And then we're going to set explode, our Boolean, to equal true. So the next time that fixed update runs, we're going to do our explosion stuff. And then, so fixed update is running 50 times a second. This is our physics update loop, right? As opposed to update, which is running at a variable frame rate. Might be 60 frames a second or 90 frames a second or 10 frames a second if your game is really badly optimized. Generally, you want to try to hit 30 to 60 and then 90 if you're in VR. So in this case, we're going to check if explode is true, then we're going to do our explosion stuff. The first thing that we're going to do is we're going to declare an array of colliders called hit colliders. So an array is a collection of colliders, and we're going to fill it with the results of physics.overlapSphere, right? So physics.overlapSphere is a bit of a tongue twister. Physics.overlapSphere is another physics function like raycast where we can check an area of the world and see what's there. In this case, it's casting an invisible sphere out around the position where we're going to have it start, which in this case is the transform position of the projectile. So it's going to start at the projectile and then create a sphere with a radius of blast radius. So around 1 meter around the position of the projectile's position. And it's going to store all the colliders that it overlaps with in this array hit colliders. Then we're going to use a for loop to go through each of those colliders that we found. And the first thing that we're going to do is we're going to check, let's make this a little more readable, we're going to check if the current collider in our array has an iDamageable component. So therefore, iDamageable is not equal to null. Now remember, in the raycast shooting example, we just checked for enemy damage. So here we're extending the system a little bit, and I'll show you the iDamageable approach. But if you wanted to keep this simple and only damage the enemies, you could just put in get component enemy health, right? Then we're going to, so if we do have a damageable component, then we're going to say hit colliders I.get component iDamageable, and we're going to call the damage function and pass in our damage variable. Just like we did our damage with our raycast shooting, we're going to do the same thing, but now we're going to do it for everything that we found inside this physics overlap sphere. Once we've done that, we're going to get a component reference to the rigid body on the damageable object that we found, and we're going to use add explosion force. So add explosion force is the summary. You can read the summary here. It says applies a force to a rigid body that it simulates explosion effects. So this is just a kind of little handy physics function that allows you to blow things up, which is pretty nice to have. And so what we're doing here is we're providing the force, which is 6,000, the explosion position, which in this case is the transform position of our object, of our projectile, and then the blast rate, we're using the blast radius for the explosion radius. So it's the same as the physics overlap sphere. So everything within the physics overlap sphere is going to get pushed by the explosion force if it has a rigid body attached. And then we're just going to say this.gameObject.setActive false. We're going to deactivate our projectile. And if none of this, if the thing that we collided with did not have we did not find anything damageable, we're just going to turn off our projectile. We're just going to set this, call gameObject.setActiveFalse to deactivate it. And we don't need to loop through and look for things. We don't need to, try to add force to things that are not damageable, like the walls, for example, or the maze. So let me just take some questions for a moment, and then I'll explain what I was doing with that iDamageable, which is called an interface. Let's see how everybody's doing. Just going to scroll back. Okay. I am not shouting asks, how would you implement throw strength onto launching the projectiles? There's a lot of ways you could do that, but you could do something like if you click and hold down the mouse, the strength gets more powerful, and then when you release, it launches at that strength. If you want, there's actually an example script that does exactly that in the tanks demo project that we did. The tanks, you can hold down to charge up your shot and then shoot it a longer distance. I'm pretty sure it uses almost exactly the same projectile-based shooting that I'm describing here. Excuse me. Yeah, Dude C 2004 asks, would this work for iOS games or would it be too much to handle? No, this would be fine. The more physics, if you had hundreds of physics objects bouncing around, you would probably start to see some performance costs, but there's plenty of games on iOS that do physics stuff using Unity and are fine. You just have to be a little bit mindful about not overloading it. But shooting, 2 or 3 grenades and blowing stuff up, no problem. All right, so let us continue. So the other part of this, so as I said, you could just do this with one script called enemy health, and then you would just do get component enemy health, and then just enemy health.damage, and do it that way, and life would be simple, right? But let's say you wanted to do something a little different. Just reloading. Like I have these boxes here on the ground, this debris, and they just have a rigid body, and then they have a script attached called box damage. And if you'll notice, if I shoot them with a grenade, they turn red. The ones that are damaged turn red, right? And I could also shoot them with my handy... Oh, no, I can't, because my my gun is currently looking for an enemy health, right? But these are using the iDamageable interface. So the way that this is achieved is we're going to use what's called an interface. And this is really simple. All it means is that we're going to, instead of only having our box damage script inherit from mono behavior, we're just going to add a comma and then the name of the interface that we want it to subscribe to. And so what we could think of an interface as a sort of a code contract for a class. So the class must implement certain functions in order to subscribe to the interface. So in this case, we have the only thing in our interface, which is here. It's called iDamageable. You don't need the I, but it's just kind of a convention so that you can remember that it's an interface. Super simple. The only function that something needs to have in order to meet the requirements for iDamageable is a function called damage that takes an integer parameter damage. So box damage meets that requirement because it has public void damage. And in this case, box damage just sets my renderer.material.color to red, whereas our enemy health also is iDamageable, and it subtracts health points and checks to see if something is defeated, right? So we're calling the same function, but on different objects and getting different behavior. And so then to make our raycast work, we just need to change this enemy health to an iDamageable, and then just do get component iDamageable. And so now, in addition to being able to shoot the target, the enemy, we should also be able to shoot. So we can shoot the enemy, and now we can shoot the boxes as well. So you could do this if you wanted to have, let's say, destructible environments, or you wanted to put like bullet decals on the wall, or you wanted to have some other mode of interaction that, you know, all these types of objects react differently to getting shot, right? Which makes sense. The enemy units would react differently to getting shot from, say, a box or a wall or whatever. And so using an interface is one way to do that. So, see how I'm doing on time. Ooh, wow, 120. Man, that went longer than I thought. Oh, no, 4:05. No, right on time. Woohoo! Okay, good. I just started early. Excellent. Okay, so that is our presentation for today. That's our material. If you'd like a recap of it, I'm going to be doing a repeat on Monday. I think it'll be largely the same. I have one idea that I might try to rewrite the interface a little bit to have the damage script spawn the particles or play the particles instead, but we'll see if that works. But basically, it'll be the same. But if you want to review or you know somebody who missed it and you want to recommend they check it out, have them come on Monday. And then I will be creating shortened, persistent videos about each of these topics. So there'll be 10, 15-minute videos that'll go up on YouTube without all the questions and chatter. This will be archived on Twitch soon if you want to watch this again. And yeah, thanks for checking it out. So I'm going to hang out, take some questions. I can answer a few off-topic questions as well. Thanks to Duck for joining us. Much appreciated, dude. With all these people in the chat, that was a huge help.